Hello all. Today we'll be solving a question given in GATE 2018. Consider the unsigned 8-bit fixed point binary number representation below B7, B6, B5, B4, B3, B2, B1, B0, where the position of the binary point is between B3 and B2. So the binary point is somewhere here. Assume B7 is the most significant bit. Some of the decimal numbers listed below cannot be represented exactly in the above representation. So we are given 4 numbers. We have to find out which of the following statements is true. The NPTEL video reference is module 2.1 on binary number systems. Course name is Foundations to Computer Systems Design by Professor V. Kamakoti from IIT Madras. Now let us look at the useful data before solving this question. A number system is a system used to represent or express numbers. So we are well familiar with the decimal number system. It is the most commonly used number system with base equal to 10. So what I mean by base is, base defines the number of symbols that are defined in the number system. So for the decimal number system, if I say the base is 10, there are 10 number of symbols defined in this number system, which is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are 10 symbols defined in the number system. Now the binary number system is another number system which has base 2. Base 2 meaning it consists of two symbols, 0 and 1. So a binary number, let's say, is represented in the form of a bit pattern. Let me write one bit pattern which is 1, 0, 1, 1, point. Let's say there's a decimal point as well, 1, 0. Now, to convert this into decimal, what we give is let us just focus on the integer part for now. From the right to left, from the LSB or the least significant bit to the MSB or the most significant bit, we give some weight. Let's call it 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. So the bit pattern 1, which denotes 1 into 2 to the power 3 plus 0 into 2 to the power 2. So this is the weight for this binary number. Weight, W-E-I-G-H-T, weight, plus 1 into 2 to the power 1 plus 1 into 2 to the power 0, which comes out to be 11. Okay. So now let us focus on this fractional part. For the fractional part, it starts at 2 to the power minus 1, 2 to the power minus 2. So this will be 1 into 2 to the power minus 1, which is 1 by 2, which is 0.5. So this number represents 11.5. So this is how we can convert a binary number to decimal. Now let us convert this number, which is this decimal number, into binary. Now let us only focus on the integer part first. To convert 2, what we do is we do repeated integer division. So and we divide by 2. So if we divide by 2, it is 1, remainder is 0. And once we reach 1, then we stop the algorithm and we read the numbers from left to right. From bottom to top we read the numbers. So for 2 it is 1, 0. To convert the fractional part, what we do is we keep on multiplying by 2. So if we multiply by 2, it is 0.25. And we look at the integer part. In this case, it is 0. If we again multiply it by 2, we get 0.5, which is 0. The integer part is 0. And if we multiply 0.5 by 2, we get 1.0 by 1. And we read it from top to bottom. So this number in binary is nothing but 10.001, 2.125. Now let us look at the numbers that is given. Now first let us convert 31.5 into binary. Okay. Let us first convert 31 into binary. Remainder is 1. 7. Remainder is 1. 3. Remainder is 1. 1. Remainder is 1. So if we read from bottom to top, right? Sorry, this is. So if we read from bottom to top, this is nothing but 11111 point. To convert the decimal part, we multiply it by 2 unless we get the fractional part as 0. So here we get 1, so it will be 1. Now given in our question it was 7, it said that B7 is the least significant. 7, 6, 5, 4, 3, 2, 1. So as we can see, the decimal point is between B3 and B2, and we are able to represent this number using the representation that was given precisely. So this is one of the numbers that we can represent using the number representation given. Let's look at 0.875. So for 0.875, the decimal integer part is 0, so that is nothing but 0, 0, 0, 0, 0 point. Let's convert 0.875 into binary. So you have to multiply it by 2, which is 1.75. 0.75 multiplied by 2, which is 1.5. 0.5 multiplied by 2, which is 1.0. So it is 1111. This is for 0.875. So again, this also we can represent using the bit pattern given. So 0.875 also we can represent. Now let us look at 12. You can do the math now on your own. I will tell you the answer for 12, which is 0, 1, 1, 0, 0 is the binary for 12. Let us convert that number, that is 0.100 to decimal. So 0.1 into 2 is 0.2. 0.2 into 2 is 0.4. 0.4 into 2 is 0.8. 0.8 into 2 is 1.6, and so we can go on. So what we can see is the bit pattern that was given, that is 3 places up, 3 points after the decimal. We need more because this will go more, right? 0.6, this. So this will go. So this will go further, seeing 0.6 into 2, which is 1.2, 0.2 into 2, which is 0.4. So this cannot be represented exactly. Similarly, you can do the calculation and find out that this also cannot be represented exactly. So only 1 and 2 can be represented. So the correct answer to this question is only 3 and 4 cannot be exactly represented, right? So I hope you all get it. Thank you.